Hey everyone, how's it going? Well, today we're going to be talking about solving a PDE with constant coefficients. In the previous example, we saw that if you have a PDE of this form, right, with constant coefficients a and b, its solution is the function u of xy is equal to f of bx minus ay. So if we look here, later we'll see a video about the shortcut, but if we look here, then we can just plug in, right, -3 and 4 for a, and that'll be a solution. And we'll do a video where we see that with the shortcut and we'll check our solution. But if you want to go and take it the long way, which can be beneficial because it gives you a better understanding of what you're actually doing, and you can also manipulate the equation beforehand if you have something that's a bit different. But first off, what you want to do is, once again, let x prime and y, select x prime and y prime. So we have let x prime equal ax plus by, and we have y prime equals bx minus ay. So we know here, for example, we know that a is equal to 4 and b is equal to -3. So we make those substitutions with x prime and y prime, we would get the following. X prime equals 4x minus 3y, and y prime would be -3x minus 4y. So far so good. Now we need to change our partial derivatives from u of x and u of y to u of x prime to u of y prime. So let's first find those. So let's see, we know that u of x is equal to partial u, partial x. We're going to change variables here. Let's see, partial u, partial x, partial u, partial x. And then we are going to take the derivative of u with respect to x prime, and y prime, and y prime. So let's take care of that. Let's see. So first one, remember, we do not know what function u is, so we can't take the derivative of it with respect to x prime. So you leave that as follows. Derivative of x prime with respect to x. So that's just 4. That's 4. And then derivative of u, it's going to be u y prime. And derivative of y prime with respect to x, it's going to be -3. Now change for y. It's partial u, partial y. Respect to x prime. Right, so the first two stay the same. Derivative of x with respect to y, so that's going to be a -3. U with respect to y prime. Let's see, y with respect to y, so it's going to be a -4. So now we have that u of x is equal to 4 u of x prime minus 3 u of y prime. And here we have u of y is equal to u of x prime, that's -3 in the front, of y prime. So -4 u of y prime. Now we have to go back and plug it into our original equation, the one up here, right? U of x, u of y, u of x, u of y. And we get the following. We would get, let's see, 4 . minus 3 parentheses, this is minus 3 u of x prime minus 4 u of y prime. That's equal to 0. Distribute, simplify a bit. Distribute with the following. These two will eliminate each other. You're left with just the following. You're left with plus 9 u of x prime equals 0. Factor out the u of x prime. So you can, I guess you could do this 16 plus 9. Doesn't really matter what it is. U of x prime equals 0, or you can combine like terms. Either way, you divide by this item here, so that's 16 plus 9. Let's give us 25. So 25 u of x prime equals 0. And either way, you get u of x prime equals 0. Now here, that means that the partial derivative of u with respect to x prime gave us 0. So we want to integrate with respect to x prime. That means that our previous function was probably a function of y prime. So then we get u of x. U is equal to f of y prime. But we stated earlier that y prime is equal to the following expression. Y prime is equal to this here. Y is equal to negative 3x minus 4y. So we would get u of x, y is equal to f of minus 3x minus 4y. That is the solution to for u of x minus 3 u of y is equal to 0 is the following. And if we recall earlier, we said that the solution to any of these would be the same form. Right? If we look, said that the solution to this type of problem is this form here. And it does make sense if you think about it for a second. We have 4u of x minus 3y. So here a would have been 4, b would have been negative 3. We plug those in here, we got an f of cb that's negative 3x and 4 minus 4y. So we would have gotten the same exact thing if we would have just plugged it into our equation. We're just taking those items and plug them into the equation, gotten the same thing. But take the longer route, you might learn a couple extra tips and tricks that you can use for other problems.